So today we're going to add some notes into our spiral about the new unit that we started called Simply Similar. And we're going to be working in pages 77 through 79. Go ahead and write this title at the top of all three of those pages where we'll be taking notes today. Ten more seconds. Okay, and the first page, page 77, I actually didn't write the title on top of this one because this is just going to be our unit cover page like we always do. So go ahead and take out your highlighter. And at the top, I'm going to write Unit 4. And nice and large, Simply Similar. Okay, on page 78, we're going to be discussing two definitions of the two words that this whole unit is sort of about. And actually, we're not even going to glue it in just yet. All you need is this handout right here. And we're going to be talking about the words similar and congruent. So let's start with the word similar. Similar. I want you to take about 10 seconds to think about what that word similar means. If I say that two items are similar, or two shapes or two figures are similar, what does that mean? This just happens to be an example that I found on my desk of two items, two binder clips that are similar. If I said that these two binder clips are similar, that means that their only difference, you can actually see, the only difference that these two shapes, these two figures, binder clips have is their size. Okay, so for my definition, I'm going to put shapes are similar. When the only difference is their what? Their size. Okay, and the key characteristics about similar shapes we actually have already learned, and I'll give you a hint. There are 3 characteristics for similar shapes. Okay, so the first characteristic was that the shapes or the figures have the same general shape. They have the same angles, but not just any angles, the same corresponding angles. And that means the angles that are in the same place. And the third one is that the 2 shapes have a scale factor. Okay, so here's our example of 2 similar shapes. So first, let me start with a small rectangle. And this small rectangle has the dimensions of 4 inches by 2 inches. Okay, so that is my small rectangle, and there's going to be an enlargement. If you remember, the word enlargement means the rectangle is going to get bigger, right? So I'm going to draw a bigger rectangle down here. And the dimensions for this bigger rectangle are going to be 8 inches by 4 inches. Okay, so looking at those 2 shapes, first we go through our key characteristics to make sure that they are in fact similar rectangles. So number 1, are they the same general shape? Well, yes, of course, they're both rectangles, so check. Number 2, do they have the same corresponding angles? Well, if you think about it, rectangles, all of its angles are how many degrees? Right, 90 degrees, because they're all right angles. So this angle, which corresponds with this one, 90 degrees, 90 degrees, 90 degrees, 90 degrees, and 90 degrees. So they are all corresponding angles, they're all the same. So that is a second check for this characteristic. And the third one is that there is a scale factor. Looking at these 2 rectangles, is there or is there not a scale factor? Yes, there is. The scale factor is from small to large, so going from the small to the large, the scale factor is 2. Okay, so that is why this is our example. And now let's look at a few non-examples actually. We're going to do non-examples for each one of the characteristics. So for example, for the first one, the characteristics say that they have to be the same general shape. So an example of 2 shapes that are not same general shapes would be if I had a triangle and I was going to a square. These 2 cannot be similar shapes because they are not even the same general shape. Okay, here is the second example. This time, the second characteristic is that they have same corresponding angles. Okay, well, let's say that we have 2 triangles. I have this equilateral triangle, and then I have this right triangle. And a right triangle means that there is a right angle in the triangle. Looking at these 2 triangles, I can see that this one has a 90-degree angle and this one does not. So I know that the corresponding angles are not the same. So those 2 are not similar. And for the third characteristic, I'm going to show you 2 triangles that don't have a scale factor. So for example, if I was going from this large right triangle, again with the 90-degree angle, and its dimensions are 6 meters by 8 meters. And it's going to be reduced. What does reduced mean? Reduced, like reducir, means to get smaller. So I'm going to draw a smaller triangle over here. Still a right triangle. And the dimensions are 2 meters by 3 meters. Okay, so go through those characteristics with me. Are these two the same general shape? Yes, they are both right triangles, okay? Second, do they have the same corresponding angles? Well, the only one that I can see is this 90-degree angle, and it looks like it. They have 90-degree angles, and they got these two other angles over here. So possibly. I can't really tell without the other two dimensions, but so far it looks good. And now the scale factor. Well, let's see if there is a scale factor for the shape. So we're going from large to small. So we're being reduced. What is the scale factor from 6 to 2? I know you might want to say dividing by 3. Technically, yes, you're correct. We are dividing by 3 mathematically, but scale factor, remember, is the number we multiply by. So we can't say 3 because that would mean that we're multiplying by 3, but we're not. We're technically dividing by 3. So the scale factor instead has to be 1 over 3 because that means the same thing as dividing by 3. Now, is that the same thing for going from 8 to 3 times 1/3? No, that is not correct. So I know that these cannot be similar triangles because they don't have a scale factor. Okay, and that's what the word similar means. Okay, on the other side, we are going to discuss the word congruent. Congruent. Now, while the word similar means shapes are similar when their only difference is their size, for example, those 2 binder clips that I pulled out earlier, congruent is when 2 shapes are exactly the same. Exactly the same. And the characteristics for this is that they're the same size and the same shape. Same size, same shape. The exact same thing. Okay, so for our example, we're going to draw 2 right triangles. Here's my first right triangle, and the dimensions are 3 inches by 4 inches by 5 inches. And it's got a right angle right here. Now, if I'm saying that I'm going to draw a congruent right triangle, and congruent means exactly the same, that means that I'm drawing the exact same triangle over here. As best as I can. If they are exactly the same, this triangle and it is now this triangle, what is the scale factor? Very nice. The scale factor is 1 because 3 times 1 is 3, 4 times 1 is 5, and 5 times 1 is 5 as well. So our scale factor is 1. Okay, and now let's look at some non-examples that go with our characteristics for congruent. So the first one says they have to be the same size. So for my first non-example, we're going to do 2 that are not the same size. So let's say I have a small right triangle right here, and then I have a large right triangle over here. not the same size, so they're not congruent. And to go with my second characteristic, it says they have to be the same shape. Well, now for my second one, I'm going to do a star like this that's open, and then one of these stars. Okay, those are both stars, but they're not the same shape. They're not the same type of star. I could even do a square, a heart to a square. And again, those are not congruent. They're not the same. They're not the same size. They're not even the same shape. Okay. Now that we're finished with our Venn diagrams, now we can add this into our spiral on page 78. And actually what I'm going to do is I'm going to fold this in half because it doesn't really fit like this. So I'm going to fold it in half. And on the front, like this, so we can flip it open when we need to, I'm going to write similar versus congruent. And then I'm going to glue this right into my spiral. Make sure that you're four-corner gluing, as always. Okay, and now you can flip it open when you need to review those definitions right there, and we can just close it. Okay, so if you flip over your spiral on the next page, we're on page 79, and we are going to be looking at we're going to be using this little handout right here, and we're going to be looking at some examples and deciding whether they're similar or not. Now, let's see. You're going to want to glue this in, the handout, all the way as far as you can to the right. We're going to be making some notes here on the left-hand side as we go along, and you're going to need as much room over here as you can. So as you need to glue this all the way, and I mean all the way to the edge of your spiral, like right next to the edge. Get it as close to the edge as you can. As close. There we go. Mine's pretty much on the edge right there. Okay. So looking at example number 1, it asks us, are these two shapes similar? Okay, well, if you remember, before today, we had already sort of discussed why shapes are similar, and we talked about how they have to meet 3 characteristics, and we actually reviewed them on this page if you don't remember what they are. There are 3 characteristics that all similar shapes have to follow. And I asked you to, every single time that I ask you if they're similar, you need to write them out and make yourself a little checklist. What are the 3 things that have to happen for these shapes to be similar? This is my little checklist. Okay, the first thing, same general shape. Okay, the second thing, same corresponding angles, very good. Not just any angles, same corresponding angles. And the third thing is that they have to have a scale factor. Okay, so that's our little checklist. And the first thing that we're gonna write is off to the side over here, a little reminder to you of what is scale factor. What do you know about scale factor? Scale factor means to what? Multiply, right. Multiply. The number we multiply by. Okay, so I just wrote that off to the side. All right, so let's look at these two triangles and see if they're similar. So first things first, are they the same general shape? Well, yes, this one is a triangle, this one is also a triangle, so I can put a check. Good, we're off to a good start. Okay, the second characteristic says that they have the same corresponding angles. Well, it's kind of hard to tell here because these two are not labeled, but these two are both right triangles, which means that they both have a right angle, and that's this one. And that means that these two angles are 90 degrees. And they're in the same location, so check. They also have the same corresponding angles. Now for the third one, we're looking for a scale factor. Okay, and then down here, I sort of specify which scale factor we're talking about, because remember, if we're going from this large triangle to this small one, our answer is going to be one thing, and if we're going from the small one to this large one, it's going to be a different answer, okay? So let's look at the first one. It says scale factor small to large. Well, if I'm going from small to large, so that means 9 to 27, 12 to 36, what is the scale factor? Times 3, right? Oh, and actually I don't even have to write the x because scale factor means to multiply, so I could just write 3, and that's my answer. Okay, that's if I'm going from small to large. What if I was going from large to small? Okay, raise your hand if you wanted to say divide by 3. Yes, you are technically correct. We are dividing by 3, but remember, scale factor means multiply. So you can't say divide by 3. Yes, you're correct, but we have to say 1 over 3 because it means the same thing as dividing by 3. I'm going to even write that down. Means divide by 3. Okay, so was there a scale factor? Yes. And since these two triangles meet all 3 characteristics, then were they similar? Yes. So my answer to the question is yes, but this is my explanation, and this is what I need to see from now on if you're asked about similar shapes. Okay, let's look at example number 2. So it's asking us again if they're similar. Well, we're going to have an answer here, yes or no, but what is your explanation going to look like? Ooh, very nice. Those 3 items, that little checklist, every single time, because these are the 3 things we're looking for. Always looking for those 3 things. All right. I'm going to give you about 1 minute to try this problem on your own, and then we'll discuss the if they're similar, and if they're similar, then what is the scale factor. This is a good problem because not only do you have to find the scale factor, but there's also a missing side that you're looking for, so be sure to try that out. Okay, time's up. So hopefully you noticed that these two shapes, even though this one is slightly turned, they are actually the same shape, the same general shape. They're both trapezoids. This one has just been rotated a little bit to the right. So they are the same general shape. It's hard to tell here, but if you remember when we were working with the wumps, and I gave you the patty paper, this is not patty paper, but it was like, it looked kind of like this, and if we traced the shape and we put it over here and we lined up those angles, we could actually see that those angles are the same. They are corresponding angles. So the last thing we're looking for is if there is a scale factor. Well, if we're going from, it doesn't really tell us which direction we're going, so I have to assume, like when I read a sentence, I'm moving from left to right, that we're moving from this shape to the smaller shape. So is this an enlargement or a reduction? Reduction, right, because it's getting smaller. Now, we have to figure out which of these sides correspond to each other. Like for example, the 48. What side corresponds with 48? It has to be the sort of like the bigger base, right? So it has to be this one right here. Okay, so 48 corresponds with 4. What about, let's do this one, the one right on the right. 72 has to correspond with 6. Okay, what about this little side over here? 36 has to correspond with 3. And 78 has to correspond with X. Okay, so those are the sides that correspond with each other. I know it's turned. Imagine it if you flip back this way, then it would be the same. If it rotated back, sorry. Okay, so if I'm going from 48 to 4, and I know that it's scale factor, so I have to multiply by something. But really, think about it. How do we really go from 48 to 4? I mean, mathematically speaking, we divide by how much? By 12. But remember, scale factor means that you multiply. So instead of saying 12, we're going to say 1 over 12, because it means the same thing as dividing by 12. And that's going to be the same for all of these. Okay, so my scale factor from large to small is 1 over 12. Raise your hand if you got 1 over 12. Very nice. Good work, good work. Okay, so a couple things to write down off to the side real quick before we get into solving for X. I'm going to write 2 more notes off to the side. Scale factor. We know it can be a whole number, but it can also be a fraction or a decimal. Okay, so in this example, it was 1 over 12. This is our scale factor as a fraction. What if I wanted to get this as a decimal? What would you need to do with 1 over 12? divide. Very nice. Okay, and I'm gonna add 2 more notes actually as well. Right here, when the shape was getting, well, for example, in this one, when the shape was getting larger, so when we went from 12 to 36, from small to large, you'll notice that the scale factor was greater than 1. It was 3. Whenever we were going from small to large, it was 3. And when we were going from large to small, it was a fraction. It was 1/3. So think about it. What happens? Oh, you couldn't actually see that. Sorry. What happens when the scale factor is 1? If the scale factor is just 1, that means that our shape stays the same, right? Scale factor of 1, kind of like we did in this example. The scale factor was 1, so our triangle stayed the same. Same thing, not smaller, not bigger. But when we wanted to make it bigger, the scale factor was greater than 1. It was 2. And when it was smaller, when we were making a reduction, this one's not an example, but like this one, when we're getting smaller, we had a fraction. We had a number less than 1. So I'm going to write that off to the side. When the shape gets larger, the scale factor is greater than 1. So when it's getting larger, scale factor is greater than 1. And when the shape gets smaller, the scale factor will be less than 1. Okay, so those are just some hints to you and some things to remember about scale factor. If the shape is getting bigger, that scale factor has to be a number that's going to be greater than 1. And if the shape is getting smaller, then it's going to be something less than 1, like a fraction or a decimal. Okay, but back to our problem, back to example 2. And actually, we can answer the first question, which is good. We said they're the same general shape, same corresponding angles, and there is a scale factor because this multiplying by 1/12, which does mean divide by 12, works every time. So there is a scale factor. Perfect. But the last question for this problem is to find the value of x, which is this guy right here. We're looking for x. How much is x? Well, how are we getting from our big shape, from our large shape, to our small shape? It says times 1/12, which just means what? Divide by 12. It means the same thing. So that's what you needed to do to figure out that missing length. Okay, and what did you get for your answer? Should have gotten a decimal. The correct answer should be 6.5. Raise your hand if you got 6.5 for this one. Nice, hands down. Okay, and now the last one, example number 3. This one is just asking you whether or not these two rectangles are similar. And this is where you're supposed to write the 3 characteristics. So I'm actually going to turn these into little check boxes like we've been doing this whole time. Go ahead and write down your 3 characteristics, and you have 1 minute to answer the question, are those 2 rectangles similar or not? All right. So raise your hand if you think the two rectangles below are similar. Yes. You put yes for your answer. Okay, hands down. Raise your hand if you put no, these two rectangles are not similar. All right, put your hands down. Okay, so let's see if we can figure out who is correct. Are those two rectangles similar or not? Well, you should have your 3 characteristics written down here at the bottom and use them as a checklist. So for the first one, same general shape. Are these two the same general shape? Yes, absolutely. They are both rectangles. So I can put a check right there. For my second characteristic, I know it should say same corresponding angles. Raise your hand if you put corresponding angles, not just angles. Yes. I'm giving you a high five right now. Same corresponding angles. And looking at these two, they're rectangles, and I know that all angles in a rectangle are 90 degrees. These are 90 degrees, these are 90 degrees. And in this rectangle, it's a rectangle, so they're all 90 degrees. So, are they the same corresponding angles? This one, to this one, to this one, to this one. Yes, they're all 90 degrees, so check. And the third one, you were supposed to see if there was a scale factor. Okay, so if I'm going from left to right, if I'm going from the small rectangle to the large, first of all, is that an enlargement or a reduction? Enlargement, very good. Enlargement means that they're getting bigger. Now, let's see if there's a scale factor. How do I go from 10 to 12? Or from 6 to 8? Ooh, that's a little challenging. When you're trying to figure out the scale factor, we first want to see, obviously, is there a whole number? Well, there's not a whole number, so that doesn't really help. Now, you could do what to get the number that you're multiplying by to get to this one? You could divide. You could absolutely divide these numbers and see what the number we're multiplying by. You'll end up with a decimal, and which could be the answer. But I also want to teach you how to get it as a fraction, because that's usually the first way that you'll see it. So here's the deal with similar shapes. They are proportional. With this small rectangle is proportional to this large one. So instead of just dividing the numbers, I can actually make fractions. I can make ratios to figure out what the scale factor is. So going from the small to large, I know that this side, 6, corresponds with 8, which means that 8 is to 6. And what I can do with this fraction is simplify. Divide by 2, and I get 4 over 3. Okay, and that is the scale factor. Okay, and I can do the same thing with this one. If I'm going from 10 to 12, I can write a fraction, write a ratio, 12 over 10, and I can divide both by 2. And again, oh, actually this time I get a different fraction. This time I get 6 over 5. So now I get times 6 over 5. Are those the same fraction? No, they're not. They're not the same fraction. So these two rectangles don't have the same scale factor, which means they're not proportional. So are they similar? No. Okay, and this, actually we're gonna make a little note over here so that you remember how to do that. And this is only for when you're stuck. If you're stuck and the scale factor isn't a whole number and it's not popping out to you, and it's not even, you don't even see it as like a multiplying by 3 or multiplying by 1/3 or anything like that, you just can't figure out what the scale factor is, you are going to need to make fractions. make ratios, and the second number is going to go on top. So for example, I was going from this side, from the left side to the left side over here. I put the 8 on top, 8 over 6. I'm going from the 10 to the 12, 12 over 10. And then, okay, so like I said, if it's a scale factor that you don't see very clearly, you're going to need to make fractions. And the second number will go on top. And then you'll have to simplify. Okay, and that will help you figure out the scale factor if you're not sure how to get it.